In the two beakers I've got here, I've got two exact same glow sticks from the same packet, cracked at exactly the same time. But look at the difference. This one's glowing extremely brightly. This one, not so much. Now what happens when I change the beaker that these glow sticks are actually in? Put that one over there and that one over here. What can happen? What do we notice? This one's starting to glow a bit more and this one's starting to get a little bit duller. All I did was change from one beaker to the next, and you can see the massive difference that has made to the amount of glow that's coming off this glow stick. And again, what's happened to this one? It's gone extremely dull. Now let's have a look at what these beakers look like. Turn some lights on, and you can see this beaker over here has got some ice in it, whereas this one is steaming. Now the reason behind this is collision theory. The glow comes from a chemical reaction where two molecules are colliding together and giving off photons of light. Now, what's happening here in our iced water, that reaction is very, very slow. However, in my hot water, that reaction is proceeding a lot faster, emitting more light per second, so therefore we get this lovely glow there. Why does this happen? It comes down to a thing called collision theory. Collision theory states that for a reaction to occur, molecules must collide with sufficient energy to overcome an activation energy. Now, in my cold water, I have particles with low amounts of energy, and a small proportion of the energy or the particles that are in my glow stick have the activation energy to react. However, when I heat them up, a greater proportion of these particles have the activation energy and are successful in their collisions. So in hot water, a greater proportion of particles are successful in colliding. They have the activation energy required. So that, my friends, explains collision theory.